Well, good afternoon and welcome to a conversation with Senza Fili Consulting. Today I'm talking to Dan Picker, the CTO of PureWave. And PureWave is an innovative 4G base station manufacturer who has been focusing on compact form factors for base stations. And what we're going to talk today is, guess what, small cells. And first of all, let's just put this in context. So the reason why we do need small cells is because there is a huge increase. We're seeing a huge increase in traffic. Cisco VNI's forecast an increase in data traffic of 78%. Video is going to grow 90% per year. Now, in this context, then, could you tell us why can we just put more base stations of the usual type? Why do we need small cells?
Sure. Hi, Monica. You know, as you mentioned, there's an explosion taking place right now in data traffic. With all the new smartphones that have hit the market and that are going to continue to hit the market, and the increased applications on these phones and video streaming and all these different things that are hitting these phones, the networks are being brought to their knees with an exponential increase in data traffic. So the traditional method of dealing with this is to put up macro base stations that cover as much area as possible and get signal to as many users as possible with the minimum amount of equipment, because there's only so much spectrum. The problem is that for all of this data traffic now, what you need is to make the best possible use of that spectrum, and you want to use it over and over as much as possible. And you can't do that with a large base station. Current standards of technology just don't, the technology is not advancing at the same rate that data usage is. Therefore, the only way to do it is to make more efficient, better use of your spectrum. And the best way to do that is by putting smaller and smaller base stations so that in more and more places, so that you can shrink the size of that coverage area, shrink the size of the cell, and therefore reuse your spectrum over and over again. And instead of sharing a certain number of megahertz, which translate to a certain number of megabits per second among this many people, now you do it among a much smaller number of people.
Now, what you talk about capacity, the need to use spectrum efficiently. So what are we talking here about? I mean, I looked at the sort of the backhaul requirement for small cells, and many of the people that I talk to think about something in the order of 100 megabits per second. But is that all you need? Do you need more? And what do you need it for anyway?
So we at PureWave actually, we see a vision that in the fairly near future, the coming few years, we think that the data needs of a given handset, a given phone user, may be as much as 100 megabits per second, as you mentioned. Although that seems incredible compared to today's standards, if you look a few years back, phones were handling 14.4 kilobits per second of data. So we've actually gone up 1,000 times from that to get to 100 megabits per second. We're already at hundreds of times today that. So we truly believe that that's coming. And to do that, you have to do much better than support those sort of data rates through a base station. Imagine if a network could only support that, they could only support one user at a time. And that is more than a typical base station can support today. What you need is to be able to support, you know, many times that amount so that you can handle multiple users at once. And do that at each cellular site so that a network is really handling terabytes of information, and any given base station we think needs to handle at least a gigabit per second of information in the not very distant future.
Yeah. So does that mean that the small cells might have more than one sector as well, or more than one radio?
Absolutely. So there will be small cell sites that have one radio that's going a very small distance. There will be small cell sites that have multiple radios that are covering multiple channels of spectrum with the same box, which brings up an important point about zoning as well, and how many of these base stations can we really expect to see out there? That's another big challenge with small cell base stations.
Yeah, well, and also there is a lot of interest for this type of applications for from vertical markets. So not people like the two of us with a phone, but there might be remote cameras, remote control systems, sensors. Is that going to change also the need for capacity?
Absolutely. So that's actually an excellent point, because those needs already exist today. Public safety is one such area. And we're talking video cameras. Video cameras these days are expected to be HD. So now that you have high definition, you have just, again, exponentially more data that needs to be transmitted. You also have applications such as smart grid, where you have meters at people's utility meters that could be at people's houses, at businesses, on the roofs of buildings, and those need to be automatically backhauled to a central location. Another great application for LTE and for small cell base stations. Just huge data requirements coming down the pipe.
Yes, now let's try to go a little bit deeper into sort of the practicalities of deploying small cells, because initially there has been some time where we were trying to make a case for small cells in theory, sort of at a PowerPoint level. But now that we are actually have products and you're trying to deploy them, we see that it's actually not that trivial. It's not like initially there was the thought that you just go and put up a small cell in the same way that you put up a Wi-Fi access point. It's not quite like that, but at the same time, it's also not the same as putting a cell onto a cell tower. So let's try to understand a little bit better what are the challenges and how is it going to work out. Now, first, let me ask you about spectrum reuse. So spectrum reuse is crucial because we want to reuse the same spectrum at the macro cell layer and on the small cell layer, because operators do not have that much spectrum. If you do that, there is obviously the risk that you create interference between the two, and you have to manage that. How is that going to be done?
Okay, that's an excellent question. That's one of the key challenges. There are many challenges to doing that. So there are two ways to approach this. If an operator has sufficient spectrum, then they may reserve one piece of that spectrum or one portion of that spectrum for their macro overlay network, as it's called, the umbrella network. And then they may reserve another portion of their spectrum assets for the high capacity underlay, so the capacity fill, the infill that brings the high capacity to each place of congestion. If they can do that, then the problem is reduced to interference between the small cell base stations. And the problem is at least a little bit easier because those base stations now can work with each other in a fairly close environment to coordinate. There's something that's called SON, or self-organized networks. That means that if you run those routines on these base stations, these software algorithms, they can work with each other to try to coordinate their spectrum usage, among other things, and play nicely together, so to speak. Now, in most cases, operators are not going to have the luxury of just having to worry about that within their small cell network. Those small cells are going to have to sit on some of the same spectrum as their macros, in which case now the problem is even more difficult because SON has to be implemented between the macro and the small cell network as well. This is something that started to happen today, especially in the femto category of very small base stations within homes. There's started to be some standardization of this as well, but it's got a long ways to go. This is one of the key challenges that needs to be solved to make this work.
Now, going back to that, since everything, all the elements in the network have to talk to each other, does that have any bearing on interoperability? So, because when I talk to mobile operators, they all say that interoperability for them is crucial. They want to use whichever vendor they want. They don't want to have any limitations. But if the elements need to talk to each other, you need to have solid interoperability. Is that the case?
Absolutely. That is the key challenge. It's one level of complexity to come up for a company to come up with a protocol, with a mechanism for their own equipment to talk to each other and solve this problem. That's hard enough. But the key here comes to standardization or to simply the industry working together to solve a problem for the good of the industry. If an operator is going to have the flexibility to mix different types of equipment, heterogeneous equipment in a network, in a single network, then this problem must be solved, which means that there needs to be standardization, there needs to be cooperation between different vendors, and that needs to happen for the good of the industry. If that doesn't happen, then you get a situation in which operators can only go to a single vendor, which gives them less flexibility, less cost effectiveness, less leverage, and at the end of the day, it hurts the whole ecosystem.
Right. Now, okay, now let's talk about the other part. It's sort of like what sounds a little bit trivial, like finding a place where you can put those cells, which is sufficiently stable, that doesn't have sway, that doesn't change too much. Because as you move, so the whole point of small cells is to move closer to subscribers or to the devices, which is all good, but that's also a world which is much more dynamic, that changes much more rapidly, and over which operators do not have much control. So if the tree grows, they can't just go and cut it. So how do you deal with all those challenges?
Oh, it's far from trivial. As you mentioned, it may sound trivial, but you run into a lot of challenges. The first challenge is simply that, as you mentioned, we're bringing the equipment closer to the users. We're bringing it down to where the users can access that spectrum and make the best possible use of it and minimize the loss that takes place between the base station equipment and the user equipment, so that you can deliver the best possible service. That means that now we're bringing equipment into the public domain, and you're dealing immediately with municipal zoning conditions. So every operator cannot expect to come in and place a piece of equipment on every street corner and not have a public outcry about it. People don't like to see equipment there. The cities don't necessarily like that. So that creates a few constraints. The first thing is that the equipment has to be very small, much smaller than traditional telecommunications equipment. The second thing is it has to be aesthetically pleasing. So it has to blend into its environment. The more seamlessly it can blend into the environment, the more acceptable it will be to the city governments, and the more acceptable it will be to the citizens who are going to be looking at it every day. In addition to that, you have to keep the equipment. Inexpensive for the operators, because they have to be able to place it exactly where they need it, and that may not always. Where they can put it, which may not always be where they need it. It may not be in the optimal position. So they may need to put more of these boxes than they otherwise would if they could place them in the ideal location. So there's a lot of pieces that have to come together to make this happen, while not compromising on the quality and the incredible functionality that these boxes need to deliver.
Yeah, and I guess that one issue is that you want to place the cells close to the users, where the users are, then you need to deal with the city authorities or whoever owns the assets. But then you have other issues like power, backhaul. It seems like you have multiple constraints that you need to manage and you need to optimize, which means that you need to actually plan for the network. You can't just go and put up a cell wherever you feel like you should, right? So what's the role of the planning for the network?
Yeah, that's absolutely true. So actually, SON plays a little bit of a role here as well in that with self-organized networking, every time with a small cell network, every time you put a base station in, you can't replan your entire network. So this is where these automatic algorithms come in that will help to automatically adapt to where you put it. The problem is that often where you have to put these base stations, you have to somehow get the signal out of it. You have to backhaul these base stations. You're not going to always have fiber wherever, fiber optic cable wherever you put things. That would create huge zoning problems and tremendous expense to the operator. So now you need to have a way of wirelessly backhauling this base station as well, and depending upon where you put that, that may or may not be extremely difficult. That's another challenge that needs to be solved, and there's an entire ecosystem that's springing up, or that has been around for a while as well, to help to solve that problem. Transmit power is another one of those issues. So on one side, the more power you have, the more flexibility you have to where you can put your base station, because your signal will reach farther, will reach through buildings, and so forth. On the other hand, it also, the more transmit power you have, the larger your base station generally will get, which is problematic. And also the more of a concern the general public has and the regulatory bodies have about where you can put it, because generally the public is not very happy about putting high power nearby. Fortunately, we're talking about relatively low powers in any event here, so that's not a tremendous concern, but it's always pops up in discussions with the public.
Yeah, and that's obviously an issue. You want to keep the equipment at a minimum. So I have two topics I want to talk in that direction. The first one is some operators are requiring, or at least would like to see, a small cell that incorporates both backhaul and base station. Do you think that that's going to work?
As a company, we feel that is a great eventual evolution, particularly for an operator that has a fixed spectrum that they're working from for their access network and a known backhaul set of spectrum that they want to use for their backhaul network. In that case, it could be built into the same equipment. You would have to have external antennas for the different networks so that you could point them in the direction that you need to efficiently backhaul, whether it's non-line of sight or line of sight. But the equipment could be made efficiently and effectively for such cases. However, the vast majority of cases today are such that an operator really wants to deploy a different set of solutions in different places. Sometimes they have a non-line of sight situation for backhaul. Sometimes they have a line of sight. They may want to use an unlicensed backhaul. They may want to use a licensed backhaul. Their backhaul may be at 70 gigahertz. It may be at 6 gigahertz. It may even be at 5.8 gigahertz unlicensed. It's very difficult to know what any given operator will need or want, even for the operator at any given point. For this reason, we believe that right now the best solution is to deliver harmonized solutions. So solutions, access and backhaul solutions that are separate, but that play nicely together, that look nice together, and easily interface to each other.
Mm-hmm. So another way to go to reduce the amount of equipment out there is to do some infrastructure sharing, which is not a concept that is incredibly popular in the US, much more so in other countries. But I've been talking, and I've just have another conversation like the one we are having today with Andy Sutton in the UK, from UK Everything Everywhere, and he believes that infrastructure sharing is going to be necessary to make sure that you keep the equipment out there to a minimum, and you can actually build more efficient networks. What's your take on that? What is that going to be feasible either in the U.S. or in other countries?
We absolutely believe that that's going to be a key strategy, and it's in fact one of PureWave's key strategies going forward. We believe that to address many of the concerns that we've mentioned, in particular the zoning concerns, we believe that it's going to be critically important to be able to host multiple operators within the same equipment. Again, very often these small cell networks are going to be providing infill coverage, so capacity fill underneath the larger umbrellas networks that are created by the macro cells. And in these cases, what the operators are going to want to do is get that spectrum, get that coverage to their customers in the most affordable way possible, which means that they're going to need to have a lot of these, and they're going to need to bring them close to the user. And by doing this, they create a huge zoning concern for themselves, because they have to obtain the assets to mount these things on. If they can band together with other operators and therefore have a multi-channel unit, a multi-carrier unit within one box, they resolve that problem. It also opens up a business case for neutral host environments where there's maybe a third party that owns the equipment and then leases out the different portions of it to the different operators. For operators, this can be a huge win because it's very convenient. Instead of the traditional roaming model, whereby their customers now are using the equipment and the spectrum of their competitors, and then they have to be billed, and there's a lot of complexity on the back end there, both technologically and from a business perspective. Now, with properly designed equipment, these customers can actually be on effectively their own carrier's equipment, and there's no roaming involved. It's a very seamless functionality for the user and for the operator.
Mm-hmm. Now, in closing, let me ask you another sort of general, high-level question. There are multiple technologies out there. There is Wi-Fi, 3G, LTE, and some operators really want to have LTE small cells. Others are more open to other interfaces. How do you see the deployments progressing? Will it be mostly LTE, other interfaces as well?
So today, I think that we're very much in a transitory phase. So there are 3G networks that are out there today. There are still 2G voice networks like GSM that are out there today. Primarily, the voice is being carried over circuit switched 2G networks, which is extremely spectrally inefficient. I think what we're going to see is as the much more efficient LTE comes on board, the 3G networks will gradually transition to LTE, and you will see some equipment supporting both. But I think if we look out even a year from now, we're going to see 3G starting to diminish in favor of LTE, which will be exponentially growing. And then they'll start to implement voice over IP techniques that will work over LTE, such as VoLTE, voice over LTE, and we'll gradually see the 2G voice spectrum freeing up and becoming available for more LTE. So I think that we're going to see a fairly quick transition to all LTE, all IP networks, which is really the most efficient way that the networks can be deployed.
Mm-hmm.
I'm sorry, you also mentioned Wi-Fi. I'll just throw in that Wi-Fi, PureWave believes that as a company, we believe that Wi-Fi will play a role for years to come. Wi-Fi has captured their niche in the market. It's ubiquitously used all over the place. People have it in their laptops, they have it in their smartphones, and we don't think it's going away soon. Therefore, what we do believe is that rather than fighting it, operators should embrace it, and we indeed see that that's happening. And so Wi-Fi will become a supplemental technology to cellular technologies, and I think that what you'll see is equipment supporting both.
Okay, well, thank you so much for taking the time to talk to us today.
Thank you, Monica. Thank you very much.